for joining today on this webinar. My name is Kate Crochelle. I am one of the marketing managers here at iMotions. We have a packed program for this webinar today, so I want to just get started right away. So let's start with some small housekeeping notes. As usual, as you can probably imagine, this webinar is being recorded. So if you need to drop off early, or if you have colleagues that couldn't make it today, feel free to just make sure that they sign up on the registration form that you used to sign up today, and you all will receive the recording tomorrow in 24 hours. So no worries about that. And then we have plenty of time today for a Q&A with Nam and Aaron, who are our speakers today, who I'll introduce in a second. So you can see on the right of your control panel, you should be able to put in questions for the Q&A, and that will aggregate to me, and I will come with the Q&A asking your questions after Nam and Aaron have talked about the awesome research that we did with this race car driving case study. So I want to introduce Nam. He is the Senior Neuroscience Product Specialist at iMotions. He's been here for about 5 years or more, and he has been integral in a lot of the projects we have in the sort of VR, automotive, aviation, infrastructure space. So, you know, specialized use cases with complex installs and understanding how iMotions can bring the best possible setup to those more complicated training and performance use cases. So that's super exciting. He's going to tell us all about iMotions and the driving setup that we had. And then we have Aaron Galbraith on the line as well. He is the Senior Sales Engineer at Smart Eye and has been in the industry in and around automotive for more than 20 years. So he was the one that was actually on site for the use case that we're going to bring you today. And so he's going to tell you all about how we installed the cameras in the car, how we tracked eye tracking data and facial expressions, and all of the challenges and exciting benefits that this setup comes with. So on that note, I'll let Nam take it away, and I'm going to turn off my camera and I will be back for questions. So thanks a lot.
Thank you, Kate. Hi, everybody. This is Nam, and I'm really excited today to be able to present to you a little bit of information about how we applied biometrics to the performance of training a race car driver. We're going to do a first introduction into iMotions technology and Smart Eye, as well as doing a little bit of background of exactly what biometrics are and how it can contribute to the driving scenario. We'll then take a quick walkthrough of the driving setup and what the actual studies conditions were and some of the challenges that we go into, as well as doing a quick review of how the Smart Eye Pro technology was able to overcome these challenges and actually meet them to collect good data out in the field. Finally, we'll then take a look at how data then gets analyzed and how we actually generate insights from that type of data on the back end. And then finally, of course, as Kate mentioned, we'll be doing that question and answer period at the end. So do feel free to throw it in the chat box all along the way. We'll go ahead and maybe take a break a few times to see if anybody has some burning questions. Before we get into the case, just a little bit of background about who we are and why we actually executed this study. iMotions has been a biometric software company that has a worldwide footprint with over 1,300 clients. And our world headquarters is located in Copenhagen, Denmark, which is coincidentally very closely located to the headquarters of our partners here over at Smart Eye, which is over in Gothenburg, Sweden. For the last 15 years, iMotions software has served as the backbone of many of the world's leading university laboratories, and this includes departments such as psychology, health, communications, computer science, and many, many more. Using that focus on rigorous scientific methodology, we've been able to enable some of the world's leading commercial research laboratories across the world, including areas such as product development, neuromarketing, automotive, which we'll talk to today, UI UX testing, training simulations, and much more. So what is it that we actually do? I kind of present this image of the iceberg because I think iMotions research is really, really cool, as well as going into the fact that it's kind of a nice analogy for human experience, in that the majority of what we experience as human beings can lie below the surface of what we can actually report. And this is evident in traditional methodologies like surveys that are dependent upon whether or not someone can actually remember things. So, you know, as a race car trainer, you might ask them, you know, can you remember what, you know, you were looking at when you went into turn 4 an hour ago? And this is not something that human beings necessarily are set up to do, because you can't remember moment by moment by moment exactly what you were doing and where you were going. That's what biometrics can then add into that type of story. With biometrics, you can record from moment to moment what they were doing and how they were responding. And hopefully I'll be able to show you a little bit more about that coming up. So this is the biometric software in general. In short, we modernize data collection for our clients by allowing them to quickly set up, collect, and analyze data from multiple biometric tools, including eye tracking, facial expression analysis through a camera, electrodermal response and GSR if you want to take a look at levels of arousal, EEG brainwaves, echocardiograms, electromyography, and more. By leveraging these multiple tools and approaches, we are able to record moment by moment the story of how a person experiences an event, such as a picture, a movie, a game, a training session, or whatever you want to have them go through, moment by moment. We then simplify this process by enabling a single button press to start everything all at once with the video and the sensor devices, to then give the researcher a chance to focus more on the design and collecting data versus getting everything to work together. And then finally, we give the researcher powerful tools for doing types of analysis, such as annotating events, applying algorithms to translate raw data signals into things that they can actually interpret. Before we get too much further, we should actually define what biometrics is and kind of demystify some of the thoughts around it. The real value of biometrics is that it is a way of investigating using the physiological signals that come from the body. And this can include things like how fast your heart is beating, where you're looking at a particular location at a time, how much sweat your skin is producing. That is related to things like your emotional state, how you're paying attention, and the way that you're set up to pay attention in different circumstances. The way that your cognition and decision-making processes are sort of optimized to operate in a certain circumstances, as well as your overall physiological arousal or excited state. What you have with this biodata is a moment-by-moment recording of that experience, as I mentioned before. You can think of it as experiencing a story that you were able to have, a page-by-page or word-by-word record of exactly how that story or experience made you feel. Imagine how much more insight you would have about the architecture of that story and how it drove that person's response if you had each and every single response in the order they experienced it. With all that, the next question is, why bother going through the added cost, as well as understanding and adding the added complexity of adding in multiple sensors to your study? Oftentimes, one research tool might be enough, but why add more? And the answer to that is that in reality, one modality might be enough for your initial question. Maybe you were only interested in motivation, how someone actually experiences, whether or not they're driven to complete something. A tool like EEG would be great because it's highly calibrated and tuned to be able to respond very, very quickly to their motivational state. But what if someone wants to know a little bit more about the overall experiences? There are things that, one device or one signal like EEG are really good at describing, but there's things that it can't go into. So, things like whether or not, you can describe the amount of a connection or the amount of arousal or something goes into. That's where leveraging a second sensor and having it automatically timed really helps you out. Something like GSR and ECG, which is tied into your overall, arousal state. So, as you become more excited, you might begin to sweat more, your heart begins to beat faster. It really has a really good measure of the magnitude of an emotional response, which you can then layer on top of that initial motivation. Other things that you might want to do is still leverage things like survey responses, things like what they can actually remember and experience and go through. And this is still a crucial part of the iMotions methodology. And we don't want to replace traditional methods like doing surveys. We just want to be complementary to take those insights and extend them beyond. And then you have things like the pattern of attention. Did they notice key information? Where were they driven towards at the moment in time? Did they apply attention towards the correct area in the right situations? And eye tracking then will apply that sort of insight into that type of generation. And then finally, there are other types of information out there that we can bring in, from EMG to facial expressions, that then give a sense of exactly how that person was experiencing throughout the session. Now, there is always going to be a little bit of unexplained variance, their specific mood that day, their individual history, and you do have to take that into account. But with the multiple methodologies, you're able to account for more of that variance than ever before. Now, iMotions clients do more than just go research how a driver actually goes faster. So we work with a lot of different research teams in the automotive space. For example, before we get into the performance driving results, some of our clients, it might be good to know that some of our clients in the automotive space apply biosensors for doing user interface research. This mostly involves how the emerging interfaces, the buttons, the dials, the gauges of the car actually interact with the users when you're actually pushing things, adding dials and such. The second area is overall user experience and how that actually applies. User experience is less involved in how people interact with the car and more like how the car environment actually affects the individual. And this can be things like, how does the sound of the engine or the way that the car is set up induce different types of feelings for such as excitement, car rumble? Does the car audio system, create a nice experience, whether it's excitement or soothing? Do the car materials sort of cause the user to experience a sense of luxury and all that? Using, again, with here, eye tracking is a little bit less of a importance, but things like facial expressions, GSR, heart rate can really tell a great story about how that person is experiencing that environment over time. Now, the final section and what we're going into to look at today involves sort of the larger systems, how drivers interact with larger infrastructure outside of the car, such as a track layout, or in some cases, we work with universities to look at intersection design and how those work with that in order to minimize things like casualties on the road, autopilot and driver assist technologies and how drivers actually get information about, when a car is taking over and when they should take it back. Other types of mobile assistant technology, networked in-car voice tools and such, we're able to also take a look at. But mostly today, we'll be looking at the way that drivers basically interact with the track today, and then looking at the way that you can take that biometric data and actually extend it into their training purposes. All right, so finally, now that you know a little bit about biometrics, we've finally come to the question about how biometrics can be applied to help drivers actually go faster. To start, as most of you know, going fast in a race car is a really extreme condition. It's not normal. It's a place where drivers are put in a situation where they have to make very, very complex decisions with very, very little information very, very quickly. And these decisions have huge ramifications on whether they lose a little bit of time, get into an accident, wreck the car, or possibly injure themselves. According to the literature and the instructors that we talked to, that after a certain level of competition, the main bottleneck to going faster, safely, lies in the driver's ability to actually perceive and make decisions for events and then apply the controls to the car. So you can see the little bit of the path here. So you get information coming through the eyes. There just takes some amount of time for that information to travel along that optic nerve, enter the brain, bounce around the cortex in order to make a decision, apply it to that motor area, then actually interact with the vehicle in some certain way to then either go faster, go safer, swerve, avoid a detection, make that winning turn. In discussions with the performance driving instructors we worked with, this is evident to a lot of the different types of comments that the trainees make when they're going into this in terms of like what's preventing them to go faster. They might say things like, I can't think fast enough to make that response. And this kind of goes into different types of systems like perception, anticipation, decision-making speed. Or they might say something like, I need to trust, the car or myself to actually brake later. And this kind of looks into things like confidence and emotional control. They might look at attention behaviors, such as making sure that they spot the apex before the turn so that they don't have to orient afterwards and try to catch up afterwards when they're in a situation where they don't have enough time. And then finally, they might say something like they need to be more consistent, whether across the runs in order to maintain sort of a base level of performance. And this goes along with the same levels of precision, emotional control, and repeatability. In the next study, I'm going to show you the questions that are centered around how we effectively measure the learning process in drivers and as they learn, and then enable the trainers to target the correct experiences to shape those cognitive skills like anticipation, paying attention to the right thing at the right time, to lower the delay between perception, decision, and response. Traditionally, if you were trying as a trainer to actually assess these things without biometric tools, this can actually be very, very difficult. A driver can ask a trainer can ask a driver, where did they look when they were entering turn 4? And then the person says, yes, I was looking at the apex, but then they would have to take their word for it. Hopefully, I'll be able to show you a little bit a better way next. So the study that we did on the site was a pilot data collection we did with a performance driving instructor on site at the Bondurant High Performance Driving School over in Arizona. You can see a little bit of the layout of the track up here, and it has multiple areas of the racetrack. You can see it's a desert driving environment, which posed a lot of its own challenges that Aaron will go into, as well as multiple challenging driving situations. So a lot of turns and such that will go in, and a lot of sections that we will be able to review at. So next, I'd like to be able to present Aaron to tell us a little bit more about how the challenges and the solutions for collecting data in this environment did and how the Smart Eye Pro system was able to overcome it. Thank you very much.
Yeah, thanks, Nam. So due to scheduling conflicts and COVID travel restrictions last August, my colleague Rob Wesley and I traveled to Bondurant High Performance Race School on behalf of the iMotions team. We went to determine whether or not the iMotions software, using Smart Eye Pro as their eye tracker, would be a viable solution for Bondurant, and I'm proud to say that it was. So before I get into the specific use case for Bondurant, I want to briefly overview the benefits of using Smart Eye Pro as a head and eye tracking solution. First, it's flexible, so you can freely place the cameras in the environment. It's non-intrusive for subjects, as there's nothing that subject has to wear to be tracked. Second, it's scalable. The number of cameras changes based on specific use case. It is research grade, so the data output from Smart Eye Pro is very precise and accurate, and this gives customers more control over the analysis process. And fourth, it's easy to use. So after initial setup, the system's turnkey, and that is it's easy to calibrate the cameras, calibrate the subject's gaze, and simply track and collect head and eye data for the subject. I'll revisit these concepts after I discuss this specific study, but for now I'd like to explain the customer's requirements. So as happens with most on-site tests, the requirements changed a little, and I would even say they were refined as the customer learned more about the capabilities. So Bondurant was not interested in the highly accurate gaze that many of Smart Eye's customers demand. Rather, they were simply interested in knowing if the student driver was looking out the windshield, the driver's side window, and optionally the passenger side window. Bondurant told us that an important factor for this system would be the ability for them to produce a report and or some kind of visual data they could provide to their student for a couple of reasons. The first reason was to give them a memento of their time at Bondurant High Performance Driving School. It was something they could take home and show off to their friends and family, brag a little bit about how they were driving. The second reason was, first, to provide feedback during the school session in an attempt to help the student understand what they might be doing wrong, and second, to assist the student in correcting such bad driving behavior on the spot. The third and final reason was to understand from an aggregate standpoint how all of the students in the classes were performing on the various tracks and maneuvers. After our first few laps around the Maricopa Loop, we stopped and I demonstrated the analysis features of iMotions to Bondurant. At this time, I did not have a respondent camera configured in iMotions, and Bondurant asked if we could record the students' heads and faces to better show, as Nam was saying, to better prove to the students where they were looking. Some students just don't believe that they're not doing the right thing until it's proven to them. So I configured a respondent camera, and we enabled the Afdex database in iMotions to collect emotion recognition for the student driver. After a few more laps around the track, Bondurant asked if we could also collect a video of where the student was on the track. That is a video that's collected out of the front of the windshield, basically following the vehicle. And of course, iMotions can do this. So I added another camera as the environment camera in the iMotion software. And there's more about this on an upcoming slide. Another topic that came up during discussion while on site with Bondurant was the ability to collate vehicle data. So they wanted to take things like vehicle speed, acceleration, deceleration, braking, steering angle sensor, etc., and tie all of these to other biometric data such as gaze and emotion. And this data would then be used to create a more well-rounded picture of what the student was feeling, both comparing and contrasting their emotion versus how the vehicle was being handled. So now that you know Bondurant's requirements, I'd like to discuss some of the challenges I faced while setting up the system and during driving and recording. So let me first start by saying I did not drive the vehicle as much as I would have liked to. We had one of Bondurant's professional drivers behind the wheel. All right, so in order for the iMotions and Smart Eye Pro solution to collect the required information, Again, that would be gaze direction, head position, the driver's emotions, etc. There were a few challenges that we had to overcome. First was mounting the cameras. Bondurant told us they were not allowed to make any permanent changes to the vehicle cabin. This included putting holes in the dashboard, the console area, A-pillars, nowhere. Not even the Bondurant personnel would be able to do this after the fact. So it was not realistic to expect this system to operate any differently in the future. Therefore, I was limited in what I could use to mount the Smart Eye Pro cameras and flashes. Ultimately, Smart Eye suggests using a very solid mounting solution, such as a 2020 rail or some in-house fabricated mount. However, the customer's limitations did not allow me to do this, and I decided to use a strong two-sided tape to mount the cameras to the vehicle's interior surfaces. Given the circumstances, I was pleasantly surprised at how well the two-sided tape held up, especially considering the amount of stress the system was being put under. Next, vehicle vibration was a concern for us. As mentioned before, Smart Eye Pro is a research-grade software and hardware solution. This environment is very challenging to work in as the vehicles at Bondurant are literally being put through the paces. You have extreme acceleration, deceleration, braking, and cornering. The way the vehicle is handled, especially by a professional driver, is not something that one would consider normal driving conditions, although I guess that concept really depends on which city you drive in. Anyway, these forces were of concern to me. Given all these potential problems, the camera calibration held up much better than I had originally anticipated. When checking how far the Smart Eye Pro camera calibration drifted during a lap around the tracks, I noticed roughly a 1 pixel shift between the cameras. I understand this may not make much sense to you, so to give you a perspective on what this means, in a static environment, this offset value is frequently as low as 1/6 of a single pixel difference between the collective camera images. Taking into account that this was not a static environment, but a very dynamic one, and given the extreme driving conditions, as well as Bondurant's requirements, we collectively concluded that this 1 degree camera drift was completely acceptable. Third, how many cameras should we use? For this setup, I installed a 4-camera system, 3 cameras on the dashboard, and 1 camera next to the center console. This is Smart Eye's traditional automotive setup. Their setup provides very good coverage out of the windshield, on the side mirrors, the rearview mirror, the instrument cluster, and the center console. Since Bondurant was not interested in tracking gaze on the center console region, I could have reduced the cameras to 3, that is the 3 on the dashboard, and obtained similar gaze tracking results for the study. Please note that the latest version of Smart Eye Pro now includes an AI-powered gaze algorithm that would have allowed me to expand the gaze tracking capabilities using only the 3 cameras on the dashboard, but unfortunately it was not available when I visited Bondurant's facility last year. Fourth, how did external or ambient light affect the setup? So the original plan was to use an over-the-shoulder scene camera to capture the student's gaze mapped over a view out of the windshield. The scene camera would have been used to assist in understanding where the subject was looking after data collection and during post-analysis of the recording. However, this plan had to be scrapped as the scene camera, which is just an off-the-shelf webcam, was having difficulty with the change in lighting between the interior and exterior of the vehicle. However, some later software updates now allow us to lock the exposure of the scene camera, and so this problem has been solved. In fact, Nam will show you an example of this in one of his videos. Since the scene camera was so negatively affected by the difference in lighting between the interior and exterior of the vehicle, I was unable to use it for this study. Instead, I repurposed this camera as a forward-facing respondent camera in iMotions. I was unable to use the AFDEX database in iMotions to detect the driver's emotions. Lastly, how would the hot Arizona sun and the temperatures it produces there affect the setup? During our visit, the Arizona August sun was creating temperatures reaching as high as 119 degrees Fahrenheit. As the vehicle cabin was air-conditioned, the interior temperature was well within normal operating boundaries for the system, and so there were no problems there. I did have some concern that the two-sided tape, which is normally a temporary mounting solution, might not hold up very well from one day to the next, but it didn't seem to be an issue. Next, I'd like to discuss the Smart Eye Pro configuration and hardware placement. Ultimately, based on our discussions with and understanding of the customer's initial requirements, I configured the installed 4-camera, 3-flash Smart Eye Pro DX system into the vehicle and used iMotions for data capture, collation, and analysis. This allowed me to capture head and gaze data from the driver's side window to the passenger side window, including instrument cluster, center console region. Although typically used as a temporary solution, the tape did work quite well given the circumstances and restrictions. Taking into account the paces the vehicle is being put through and all the vibration that comes along with that, camera calibration drift during even the hardest driving and maneuvers was less than 1 degree with this mounting solution, and that is amazing. This allowed me to keep the gaze direction values well within the required boundaries for this study. Hardware-wise, I used one laptop to run Smart Eye Pro, a second laptop to run the iMotions software. They were networked together. Ideally, I would have used an industrial, ruggedized PC designed for harsh environments and placed this somewhere in the vehicle, maybe the trunk under a seat or something, but we didn't have this hardware available at the time of study of this trip. In the picture on the right, I've included the locations for the cameras and flashes as circles. So there were 4 Smart Eye Pro DX cameras, those are the blue circles, 3 LED flashes, which are the yellow circles, 1 respondent camera, which is the red circle. This camera pointed at the driver to capture the driver's face and emotions, and 1 environment camera, which is the green circle, and it was placed directly behind the respondent camera facing the other direction out of the windshield. And it was used to record the view of where the vehicle was pointed. So using all of these cameras, it collected quite a bit of information, which was then presented to Bondurant through the iMotions software, and I have to say they were very impressed with the results. So on this slide, there's a video that's representative of where the Smart Eye Pro cameras were located in the vehicle, so you have some sense of scale. Unfortunately, I didn't record anything like this while I was at Bondurant. However, this video should give you an idea of where the cameras would be placed in the vehicle. So again, there were 3 cameras along the dashboard and 1 down by the center console. This is Smart Eye's typical vehicle setup and allows head and gaze data to be captured from side mirror to side mirror, including on the instrument cluster, rear view mirror, and center console regions. I would like to now revisit and expand upon the benefits of using Smart Eye Pro as an eye tracker. The Smart Eye Pro system is flexible, as I mentioned before. That is, the cameras can be placed freely within the environment. This allows us to provide a more realistic experience for the test subject, and repositioning of cameras can be performed to find the best possible view of the subject's head and eyes. External or ambient lighting conditions are not an issue for the cameras in a Smart Eye Pro system, as Smart Eye Pro only uses the light produced from its LED flashes. This means that any ambient light, including sunlight, is generally not a problem for the system. Smart Eye Pro is scalable. The number of cameras required to capture someone's gaze may change based on the purpose or use case for the system. For example, if gaze is only needed directly in front of the driver, a 2-camera solution could be deployed. If gaze is needed from side mirror to side mirror, then a 3-camera solution could be deployed. And if gaze is also needed on the center console, a 4th camera can be deployed, so on and so forth. Generally speaking, if the field of view or gaze tracking requirements are increased from one study to the next, additional cameras can be deployed to meet those needs. Keep in mind that Smart Eye Pro is research grade. What do we mean by this? Gaze accuracy is typically between 1 to 2 degrees offset, and Smart Eye Pro boasts a gaze accuracy on some subjects as low as 0.5 degrees offset. Smart Eye Pro also provides about 140 data output values that include but are not limited to gaze direction, head position and orientation, pupil diameter, eyelid opening, and many more. And many of these Smart Eye Pro output values are used by iMotions to render the head and gaze data in its environment. Smart Eye Pro is intended to be used in research environments with computers in auto and flight simulators, in automotive applications, etc., and it will provide the most accurate results in such environments. I should definitely note that it can absolutely be used in other environments such as this study, where we have a high-performance live vehicle example that we're presenting today. Once installed, the system is, once the system is installed and configured, it's quite easy to use. So we at Smart Eye understand that time is money, and we've designed the camera recalibration process to be quick and simple. It takes about 10 seconds to do. To reiterate the remote, non-intrusive nature of the system, Smart Eye Pro captures the subject's gaze without the need for subject to wear anything. The cameras are remotely placed. Smart Eye personnel will install the system and then train our customers on how to use the system. Once the initial setup and training is complete, the system is quite easy to use, especially when paired with iMotion software for performing things like biometric data analysis. Thanks, Tom. Back to you.
Thank you, Aaron. So next, let's take a look to see what the data looks like as it actually comes into iMotions. So on the bottom here, you get a replay directly from the iMotions software. And this is what it looks like when you're collecting data live, as well as what you can immediately get upon afterwards upon data completion. And you can immediately hit a button to replay this event. Here on the bottom, you can see the information coming in from the Smart Eye Pro software. Here you see a representation of the head and some of the other types of information that they're able to go into, such as all the different types of directionalities for the eyes, where you're looking at different levels, as well as the different components that are actually mapped out inside the car, such as the center console, the HUD, the windshield, the right mirrors, and the left mirrors. We're then able to take that information and then push it through a camera, as mentioned before, that can be pointed either out the top or it can be mounted behind the driver if you're interested in how they're interacting with the actual interface of the vehicle altogether, in order to get a sense of exactly where they're paying attention to. And you can see this as a visualization of this ball and line plot, which I'll get into a little bit later. By having this replay and then combining it with all the different sorts of data that we're able to access, whether it's biometric data, each of the individual data channels from Smart Eye Pro, we're able to get a really great replay and interface about how we're actually paying attention to the different elements inside the simulator. Since it's a recording, you can stop, replay, do a slow motion, and dive into every single event that they're experiencing either on the road, on the track, or whatever experience that you're going into in order to really deep dive video frame by video frame what happened second by second. Next, I'll show you how this actually applies to the track and how we collected it on the data collection session that day. So let's go ahead and first take an example of what it looks like in terms of the track conditions. So here we have our driver. His name was BJ, driving upon the Maricopa Oval. I can see if I can go in here. You can see that there's a replay of him going through the track on this side. The data is being presented here on the bottom, and then we see the camera feed coming in through here. And this is presenting a little bit of facial expression data, which I'll tell you a little bit more about later in the session. In this particular case, this driver was driving purposefully with a quote unquote wrong driving method, in that this person is driving with an inexperienced technique. We're going to be able to take a look at that by looking at the analysis of him driving through this circle. So the problem with going into the analysis is that it needs to be accessible to the person going through it. And as we were working with driving instructors, there were a lot of perceived challenges in working with biometric data that they were worried about. One was that the data was too complex. So there's all these different channels, all these different types of interpretations. A lot of them were just raw data signals. How do they go about learning how to actually interpret all this information? This led to the misconception that they needed some sort of PhD or graduate school expert to then interpret the signals. Another misconception was that the analysis was just going to be too time consuming, that everything had to be done offsite, that had to finish doing data collection, they had to send the person home, and then had to spend weeks and weeks diving through that data in a long, drawn out, deep process in order to get any sort of insights. The final misconception was that they thought that there was always need to be some sort of expensive customized tool that takes away their judgment. So sort of something that just says whether or not this person was performing well or not. And in some ways, they're right. The data can be deep. There's just quite a lot of data there. It can be quite complex, and that having the background does actually help. And if you invest in automated performance tools out there, such as like in the airline pilot industry, there can be things that automate that information. But what I hope to show you today in the next few slides is that it doesn't necessarily need to be a huge complex process, and that there are quite powerful insights that are related to training that can be replayed immediately upon being in the car with the person or after the drive. And so today we're going to focus on looking at a couple simple signals there and seeing the power of just being able to replay things in the correct time and being able to control that replay, how you're able as a trainer to be able to affect a driver's behavior overall. So first, we're going to focus on the Maricopa Oval, where we have someone driving through this portion of the track. On the bottom, you'll see an example of how our software can help our researchers mark up the recording by looking at specific events like turns, entry, and other features that help pull out and focus on specific events that they're interested in the data, such as when they actually went through and compared a specific turn every time they went around. This can be very handy to do things like calculate average behavior across sections or make comparisons. So let's go ahead and take a look first at the first section here. So here we have a replay from the software. Again, as I mentioned, this happens automatically in the car, and you'll actually see this live if you're sitting next to them with the laptop, or this is available in a replay immediately after doing data collection in our software. On the bottom here, we actually see a video output from the section of actually driving through the vehicle, this section of the Maricopa Oval. On the top, we have a visualization of the different parts of the car that you might be interested in tracking. So attention out of the front windshield, the driver's side window, different parts of, say, the car, such as the mirror, the center console, the rear view mirror, as well as the passenger side window. Next here, we're going to focus on a single data channel. This is something called intersection, which is available in the software, but you can think of it as an attention profile. What it is that each section in the car, as it gets mapped out, actually gets a value. When you look at this graph of the chart, it actually tells you if you're actually looking at that particular object. And I kind of call this an attention profile. So each value represents whether they were looking at the front windshield, the driver's side window, the tachometer, the passenger side mirror, and other such. Again, at this point, without having much training at all, it's pretty evident to see how someone actually behaves when they were driving across this part of the track without needing to necessarily do a lot of data processing on the back end. You can see that out of necessity, the person here was driving with a really novice technique. They were spending most of the time looking out of the front window and very few times actually looking out. And here you can even get a sense of the pattern and how often it actually was visited and how much they reviewed it. But you can see that this driver was actually paying attention to the front of the windshield and not spotting the apex before they're getting to the turn, even well into the turn at that point, indicating again that this driver has a very novice technique and probably will have a tougher time catching up to their perceptual abilities. So again, in order to have that ability to perceive and anticipate that turn and make those small adjustments, it's best to have a correct technique to be able to spot the turn off the side window before actually moving in, which is what we'll see next in the next replay. Here we see a representation of a more correct technique, somebody that is driving and using a lot more side windows. Again, they're intersecting with the driver's side window a lot more in the circumstances. You can see that in the replay here as their gaze goes from the center section and then drops over to the driver's side section. And there's lots more information, which I'll unpack here in just a moment. But again, in just these 3 windows, which again are available live, you're able to get a nice sense that, hey, this driver is using more correct technique. They are paying attention to the correct levels. And I don't have to ask them to see if, are you paying attention to this location? Are you using this location consistently across the drive? Therefore, you're able to document moment by moment their progression from run to run to run. This is made even more evident when you actually take the responses and look at them side by side. Again, you don't need a ton of data analysis to go in, like fancy algorithms to take a look at this. This is just simply looking at one attention profile from a signal that comes natively from the software. But using this, you can now use information in order as a trainer to track a skill that effectively, that greatly affects that driver's ability to actually corner effectively and maintain speed. Next, let's take a look at ways to actually visualize that eye tracking data overall. In the eye tracking software literature, there's 3 main ways of actually visualizing that eye tracking data, that line plot that you saw earlier. One is to look at it in a gaze replay. This is that series of lines and dots. And if you look at eye tracking behavior, when you stop to look at something, that's called a fixation, and that gets represented as a circle. And then the order and pattern of that fixation allows us to put an actual number on it. So you're actually able to follow the pattern if you go from 1 to 2 to 3 and so forth, in order to get a sense of exactly what the way that they're actually going about looking at it is. The second way is looking at a heat map, and this kind of looks at the distribution of attention overall across various experiences and turns. And so here you can take the average heat map of various experiences, entry, going into a specific turn, to see how someone actually distributes their attention. And in this case, is looking at buildings, but this could easily be specific parts of the track, specific parts of the car, and such like that, in order to make sure that they're distributing their attention evenly across this. And more importantly, what are the areas that they're not paying attention to? These areas without any color are areas that were not attended to at all. And oftentimes that's kind of some of the most important sections of what they're missing. And then finally is something called areas of interest. This is a way of extracting out statistics and other quantitative data, such as the milliseconds of time spent on average, how quickly it was before the first look was actually within these areas. Things like revisitations and how much time you spent transitioning between two areas. These can all be calculated and put out for you for some deep insights as well. In looking at some of this replay for this particular subject, we found that here we have a representation of the way that this driver was using the different areas of the car. So you can see a lot of the information was being spent basically straight out of the windshield, as you would surmise. Some sections, again, we're looking at the rearview mirror. Some was spent looking at the center console, a little bit of the rearview mirror and the information center here. And then this one did spend a considerable amount of gazes out of the particular side window. So you can then actually count and then quantitate exactly how much usage was there. If you looked at it from a heat map perspective, you can actually see here that on average, the gaze was looked at again out the front window, some of the side windows, a little bit off of the side and rear view mirror, but largely ignored areas such as the passenger side window and the mirrors and such. And then finally, you can take a look at the overall usage summary. So this is time spent at specific areas. So this is actually calculated by areas of interest. You simply draw a box around it. And then you can get information like time spent, which can get exported as a nice CSV table, which you can then take into any software to create a nice sort of replay here. Here you can look at different types of events. So time spent looking out of the front window, as well as the driver's side windows. And then using the annotation tool, you can actually generate separate tables for each individual event. So you can do this turn by turn. Every time you hit turn 2, the first run around, the second run around, the third time around, to see that progression to change over time. To show that it's very quick and intuitive to actually learn this, now that you know about it, let's take a look at a different section of the track. And this is the track entry for the Maricopa Oval when he was just getting onto the track at the beginning. And here we can see the driver is looking out the front window and then occasionally checking the speedometer, then looking out the front again, and then checking the center console. And at this point, I believe they were doing something with the power controls of the car to adjust the amount of horsepower that was particularly available there. But in just doing the training that we've seen before, then you're already able to interpret this replay quite quickly. And then having the value of looking at exactly where they're paying attention to on the location of the screen, what the track conditions were, and what the actual 3D conditions were doing, kind of give you a lot of confidence in terms of exactly what the driver was experiencing at that moment in time and how they were behaving from moment to moment. Next, we're going to explore how trainers can effectively use facial expressions to help understand a driver's response. And this is leveraging another company, partners of ours, Affectiva, that has a software called Aftex. What Aftex is a software that allows you to take a normal video camera, point it at any person's face, and then the software is able to then identify the face, draw specific landmarks on the face, and then identify outputs such as different levels of emotions, basic behavioral measures like how their head is actually tilted up, down, left, right, roll, pitch, yaw, as well as other types of overall muscle movements. So let's take a look at replay of what that actually looks like from before. So you actually see the output here of the driver going through. As the driver is going around the track, he's making different types of facial expressions as picked up by the car. The car environment was not a problem for picking up this driver's face unless the hand got in front of the face, which can be fixed by just raising the camera just a little bit so it looks over the hand instead of that. On the bottom, we see each of the individual data channels. So things like anger, contempt, fear, sadness, and disgust, which can be interesting in their own right. But what I really want to focus on, and then again, focusing on the use case of just using very simple data and not diving too deep into it, is to look at pure facial engagement, which is this gold bottom down here. Engagement can be loosely defined as the presence of almost any kind of facial expressivity. It doesn't matter if it's positive or negative. So if he's making any sort of face, make sure that he's engaged, so not being like a zombie. To apply this type of insight into the performance driving space, we're going to borrow a little bit from the literature of flow state, also called being in the zone, if colloquially. And this has been popularized by a researcher named Csikszentmihalyi. And here we can assume that, from that literature, that a driver that is fully concentrating on the task is going to have a dearth or an absence of any sort of facial expressions. They're going to be in the zone, they're going to be focused, and they're not going to be creating that much of a facial expressions. Then you can say that any sort of expressivity that happens when someone is going through this can be assumed that these are areas that there's a break in specific concentration. In this particular case, this driver was kind of playing around a little bit, to be perfectly honest, and having a bit of fun. So you can actually see the bit of expressivity of this driver going around. What this can do then is help researchers then focus in on areas where there were breaks in concentration. So rather than go through a recording moment by moment, video frame by video frame, they can go in and quickly realize, hey, there's a lot of attention and expressivity going on right here. This could be something that represents that, again, that emotional stability, that precision, their ability to repeat a stable lap time going around and around the track, so that their performance can be more even as well as more controlled overall. And this can link back to other types of emotional conditions, such as being braver and being able to brake later in turns and such as well. This effect can be seen across the different conditions that we drove around, from more correct technique to a more incorrect technique. Overall, we found that high positive affect, having fun, was related to when you were sort of having more sort of wrong technique, when they were driving a little bit slower, maybe having more breaks in concentration, as mentioned before, and that when someone was actually driving well, then they typically had less facial expressions, there was more concentration, they were able to stay in that pocket in the zone for more of the amount of time there. If you did, however, want to actually dive into the individual facial expressions, of course, that information is still there and it's kind of fun to look at. And here we can see, during that particular aggressive driving situations, there was just typically a lot of joy, a little bit of disgust, a little bit of contempt. Again, still all available for the drivers as well. Finally, to conclude, we've presented a number of powerful tools that biosensors can enable to the performance driving situation. Hopefully, I've demonstrated that the analysis, while undoubtedly can be very deep, can leverage a few key data signals, such as that attention profile signal to the attention engagement metrics, to help trainers be able to access very quick and very powerful insights for the training situation. And there's a lot more that you can dive into, especially with the deep analysis on the back end. I'd like to thank Aaron and Kate for the biometrics today for helping us out, and I would like to now open it up for any question and answers onto the chat line. Thank you very much. Hope you have a nice day.
Thank you, Nam and Aaron. Super cool. I love the data visualizations, and I hope we've inspired everyone attending to think about new ways of tracking performance and training in complex research setups like race cars. I have a quick audience poll just because we have about 15 minutes left, and I wanted to make sure that we have a chance to catch up with all of you. If you are interested in following up about the iMotions and Smart Eye solutions, we have this little poll here. So I'm just going to launch that, and feel free to answer it. And then we will, as you're answering, we'll start asking the first question. So yes, I have some questions here from the chat. And so I wanted to start with the question of how much did Bondurant, the client, know about biometrics and this type of research before they approached you? And how was the sort of like introductory process? Was it their idea and they came to you? And how did you sort of like make sure that the solution was fitting what they were asking? Maybe that's a question for Nam, and then you can pass it on to Aaron.
Yes, absolutely. So they actually did initially come to us with an interest in using eye tracking technology in order to track their drivers. So they had heard of biometric before in the past, but they didn't have any experience before actually collecting that data. And they needed to truly start from almost ground zero in terms of actually being able to set up, collect data, and then look at that data on the back end. Luckily, iMotions specializes in that in terms of both the application, the simple app software that simplifies the process, as well as supporting our researchers on the back end with expert consultations and workshops and other types of information transferring sessions to give our clients the expertise to look at, interpret, and really make sense of that data on the back end. Aaron?
Yeah, I mean, it was the same thing. So we got this through iMotions, and they asked us, because of some travel restrictions that they had, in Massachusetts at the time, if we would go out and set the system up and help them. So absolutely, we had some discussions with the client beforehand, try to figure out what exactly they were interested in. I would say I agree that their level of biometric knowledge was relatively low in the beginning.
Mm-hmm. Nice, and that's why I think it's great that you were able to sort of give them a live realization or visualization of all the data that was coming in and not making it overly complex. So I also have a question about the Smart Eye camera placement, Aaron. Did you have a consult with BJ, the client, to figure out the field of view before you installed and like making sure you knew exactly where the cameras were going to go? Were there options for that? Or was it really like you knew exactly that there had to be the 4 cameras in the different areas that you had showed us on the presentation?
Yeah, so I mean, we had multiple calls with the client in order to determine what they're interested in as far as their gaze, and were they interested in things like head position, do they want motion data recognition, things like that. And through those calls, we kind of formulate an idea of what we think will be the best. We get out and then we see the actual environment. And of course, some of that changes a little bit. Camera placement wise, as I mentioned before, the placement of the cameras is pretty standard. So we have a 4 camera setup. We put one by the driver A-pillar, one by the passenger A-pillar, one towards the center of the dashboard, and then one down usually by the center console to catch gazes down low. We kind of assumed that they were interested in the center console sub as well, so that's why we originally did the 4 camera setup. When we got out there, of course, we're on site for a couple days. They started asking additional questions. Can we do this? Can we do that? So it changed a little bit. But as far as placement goes, it was pretty standard. I do remember on this particular vehicle that the left side of the in between the driver's side door and the steering wheel, there wasn't a very good place to put it on the dash, so we kind of had to fabricate a little mount to still tape there. But otherwise, it still worked really well.
Mm-hmm. Nice, thank you. We have a question from Dylan here who's asking, I work at a motorcycle school. What about an in-helmet tracking solution? Is that something that we could potentially support? Dylan realizes that you can't get expressions because of the helmet obstructing the face potentially, but what kind of eye tracking solutions do we have for in-helmet setups?
So I know working with Smart Eye before and working through the pilot industry, we have done helmet setups. As long as the face and the visor weren't down, it was still capable. The Smart Eye Pro system was still able to track the eyes effectively for fighter pilots in that situation. So I think it would be absolutely capable of doing that in that situation. I think motorcycles is even more of a vibration-prone situation, so I think it would be something that we would have to test out. But I think it's something that is a very interesting use case, and Aaron might have a little bit more of a sense on that.
Yeah, so again, as Nam mentioned, as long as certain facial features are detectable by the system, then we can absolutely track the head and the eyes. If the visor is going to be down, as long as it's not IR blocking, there's still a chance that we could see through the visor, since we only allow infrared light into the cameras. In that case, we might still be able to do it. As Nam mentioned, we've done this in the past for aerospace customers, fighter pilots, traditional pilots, etc.
Mm-hmm. Great. Okay, I have a question from Marlene who's asking, if one of the cameras stops recording, what will happen with the full recording in the field of view? Can you still like sort of recoup, the majority of your recording data, or is it sort of all or nothing?
So I guess it really depends on which cameras we're talking about. So there are the 4 cameras in the Smart Eye Pro system, then we had 2 additional web cameras. If we're talking about the Smart Eye Pro side of things, if any of the cameras are obstructed for any reason where the camera can't see the face, as long as at least one camera of Smart Eye Pro can still see the face, we can track. Ideally, we'd like that to be at least 2 cameras. And this is easy to demonstrate as well. If for some reason there was a hardware failure, that's a different scenario. In that case, the system would probably stop tracking.
Nice, thank you. Okay, I have a question here about gaze mapping. So Ravina asks, when you have heat maps, how do gaze maps add on to that insights generation? How do you use the 2 visualizations together to create a bigger story?
Absolutely. So Where gaze maps helps is looking at things like overall pattern as well as individual features. So you get a sense of like those ball and line plots, and you know you went from A to B to C, and then the size of those dots actually gives you the time spent in that individual time. But that can be complex, especially over certain situations. Where the heat maps come into real play is that they average across time, across an event. So you could say, what is the average of turn 1 and compare it to like turn 2 versus turn 3 and turn 4. And so that helps quickly look at, again, the distribution of attention versus the pattern of attention or individual locations. And so they both have a different sort of way of, one sort of averages across time and one sort of takes time step by step by step, look by look by look.
Mm-hmm. And a follow-up question on that, could you potentially aggregate the heat map across multiple drivers if the setup was continuously recording from the same angles? How would that work in iMotions?
Yeah, so iMotions does have a way of aggregating multiple individuals towards a common experience. Now, the challenge would be that, of course, in the car, you would have to then line up, like, entry on turn 1 versus turn 2 versus the turn 3 and such like that. But it could be done. Unfortunately, things that would be slightly different would be whatever would be on the outside of the track. But, very common things like, usage of the actual parts of the car and the glasses and stuff, those things can be aggregated and then turned into group dynamics and group averages. So you can get something called a B-swarm, where you see lots and lots of gaze points all kind of going through a specific part of the car. And as well as the heat maps can then reveal like that average information, as well as the AOIs.
Areas of interest, yes.
Mm-hmm.
Cool. We only have about 2 minutes left, so I'm gonna just ask a final question, which is, what was the overall reception? I mean, you mentioned, Aaron, earlier that BJ, the client, was really excited and impressed with the results. But like, can you tell a little bit more about that, like, real-time reaction of seeing this data in replay and sort of having that live experience? And
Yeah,
what was
absolutely.
from the driver perspective? What was it like?
Yeah, so in the videos that Nam was showing, where we saw BJ's face and his excitement, his anger, all that stuff driving around the track, I was sitting in the passenger seat in a 5-point harness holding 2 laptops and trying to make sure everything was working. So that was a bit of a ride. So some of the laughing you see there is him laughing at me as I'm trying to keep myself together while he's going through very, very hard maneuvers. Overall, he was very excited about the system. He was excited before we even visited, so that was great. It's the kind of customer you love to have. And we got out there, and once we started setting up the system, we were able to take him on the track and demonstrate what it was capable of. You could just see him light up. And that's where the idea behind, I made a comment during my section where I spoke, as we were there, kind of the requirements changed a little bit. He started to realize, like, oh, okay, great, we can do this with the head and eye tracking stuff, but hey, can I see what's going on the track? And can I see the emotions of the driver? Can I just record the driver's face? Because we want to be able to supply all this information in some kind of a report to them that would allow them to be able to not only learn from their mistakes on the track, but also, as I mentioned before, be kind of a memento, something they could take home on a USB stick and share with their friends and family, hopefully be kind of a marketing piece for Bondurant to then get other people excited about going out and trying the driving school. Ultimately, it seemed like, BJ was pretty much sold on it. So then we went in and met with his management as well. And he went back out and did some things on the track while we were talking with them. And they were very excited as well. And I would say, even compared to BJ, because he had done some of the research already, that they were even less knowledgeable of the biometric side of things. So we were able to get in with them, work with them, show them what was going on in the software, kind of explain to them where we were at in the track, what was the driver feeling, what were the emotions, where were they looking, were they doing this as an incorrect drive versus a correct drive. And they were very happy with the results and what they were able to visualize.
Great. Awesome. So on that note, I just want to quickly wrap up. So thank you so much, Aaron and Nam, for your time today. I think you really sold this use case as not only in a race car driving context, but I hope that our audience has sort of figured out ways that you can apply this to a lot of training and performance contexts, maybe beyond automotive. The fact that you can track eye tracking data, combine it with facial expression data in a real life training situation can be applied across a vast varieties of research fields and applications. So if you have questions about that and how iMotions and the Smart Eye solution can help you in your research, please reach out to us. You can email us at marketing@imotions.com, or you can request a personalized demo. We actually have our product specialists like Nam showing individualized use cases live with your questions for your research area. So those demos can be really helpful in sort of like solidifying how iMotions and Smart Eye can help you. So on that note, I'm going to say thanks so much, and we will see you soon. Thanks for today, everyone.